Hello, this is Professor Keen. We've been studying Ptolemy's book, the Almagest. Last time, we talked about his chapter 3, where he defended the position that the heavens themselves were spherical in shape. Today, let's continue with chapter 4 of his book 1. Again, this is in chapter 5 in A Student's Guide to the Grade Physics Texts, volume 1. In chapter 4, he mentions that the Earth, too, is generally spherical to perception. That is, to our perception, as far as we can see, it seems like the Earth is spherical in shape. Of course, there were other people who believed that the Earth was flat back then, as well as there are people who believe that the Earth is flat now. So Ptolemy feels the need to defend this position. And so he recycles some of the arguments that were given previously by Aristotle. So you might remember some of these arguments from your reading of Aristotle's On the Heavens. One of the arguments that he provides is that eclipses are seen at different times of day or night for different observers, and specifically at times that are proportional to the distances between those places. Notice what he's doing here. He's saying, well, an eclipse happens at a particular moment in time. It happens, if you're talking about a lunar eclipse, at the moment the Earth passes between the sun and the moon. Now, different observers who are on the face of the Earth will see that eclipse, which is happening at a particular moment in time, as happening at different times of day for them. So some observers who are at one location on the Earth might see the lunar eclipse in the morning. Another might see it in the evening. Another one might be seeing it late at night. And he says the fact that these different observers see this lunar eclipse event happen at different times of their day implies that the Earth is curved into a circle or a sphere. The next thing that Ptolemy does is he goes through some of the other views that people have on the shape of the Earth. So for instance, he says some believe that the Earth is concave in shape. Others believe that the Earth is polygonal in shape, or perhaps even cylindrical in shape. So what would this imply, and why does he reject these views? Well, suppose that the Earth, and again, this might seem far-fetched to you, but there are people who must have believed this, otherwise Ptolemy would not feel the need to address this issue. So let's suppose that the Earth was concave in shape, and there are people standing at different locations on the Earth. Okay, I'll draw one person here and one person here. If the sun is going around the Earth in an orbit like this, then if the sun is rising over here, if it's going like this, the person who's standing farther west would be able to see the rising sun before someone who is standing to the east. And this is precisely the opposite of what we notice. We notice that someone who's standing farther east sees the sun rise before someone standing to the west. So therefore, the Earth cannot be concave in shape. Okay. Another possibility is that the Earth is not a sphere, but it's some kind of polygonal shape. So let me draw maybe an octagon. And people live on different faces of this octagon. Well, if that was the case, then what would happen for different people standing on these different faces of this octagonal shape? Well, their horizon would look like this, and this person's horizon would look like this. So if that's the case, then when you walked around the Earth, there'd be sudden abrupt changes in which stars you see. So as this person walked in this direction, he would see everything above his horizon, that's to the right of this vertical line, until he got to the corner. And as soon as he got to the corner, that horizon would flip suddenly, and he would suddenly see very different stars. And yet Ptolemy mentions that as you walk northward, you gradually see different stars appearing as you walk farther and farther north. Now this is true to the extent that you're not on any kind of any angular kind of terrain, but it is certainly the case that when you walk over a mountain range, suddenly you see a change in the stars that are visible. So you might see why some would believe that the Earth had some kind of polygonal or angular sort of shape. In any case, Ptolemy rejects this idea. He also rejects the idea that the Earth is cylindrical in shape. Okay, so this was another idea. Perhaps we live on the surface of the cylinder, but again, this would imply that as you walk farther north, there would be no change in the stars that you see until you got to this corner, and suddenly one would see a very different set of stars in the sky. Okay, let's go on now to his chapter 5, that the earth is in the middle of the heavens. Now, this is a little bit of a complex chapter, so what I'm going to do is so let me just tell you what he's going to do in this chapter. We're going to skip it, go to the next few chapters, and then come back to this one, okay? So in this chapter, he is going to argue that the celestial sphere, this enormous celestial sphere, on which Polaris, the North Star, and the other stars are located, if we draw an axis line straight down like this, he's going to argue that the Earth is exactly on axis. It's right at the center of the celestial sphere. It's not to the right of the axis. It's not to the left of the axis. For that matter, he's going to argue it's not up or down the axis. It's directly at the center of the heavens. And he's going to present arguments for why he thinks that is the case. So we'll come back to that in my next lecture. But let's move on for now to his chapter 6. In chapter 6, which is on page 48, whoops, I guess it would be 49, chapter 6, he argues that the earth has a ratio of a point to the heavenly things. What does he mean by this? Well, he means that if you compare the size of the earth and you compare that to the size of the celestial sphere on which the stars are located, the earth is extremely small compared to the celestial sphere. Why does he argue this? Well, he says, if you are standing on the earth, let's put a person right here on the side of the earth, and let's draw a line that is tangent to the earth, right here. That would be the horizon of the person standing on the earth. And that horizon, he says, bisects the celestial sphere. In other words, the plane of this horizon cuts the celestial sphere in half. How do we know that this cuts the celestial sphere in half? Well, if we draw, I'm going to draw a line right here representing the ecliptic. Remember, that's the band along which the signs of the zodiac are located. So there are 12 constellations, which are identified as the zodiac constellations of the zodiac. They lie along this band on the celestial sphere. We talked about this a few lectures ago. And the point he's making is at any moment in time, there are 6 constellations of the zodiac that are above your horizon and 6 that are below your horizon. That is, the horizon cuts the celestial sphere in half. Now, that would only be the case if the Earth were very small compared to the celestial sphere. If the Earth were larger, let me draw another picture down here. I'm going to draw the celestial sphere here. And let's suppose the Earth was appreciable in size compared to this celestial sphere. Here's the axis of the celestial sphere. Here is the equator of the celestial sphere. And once again, the ecliptic. If you were standing on a large Earth, one that had appreciable size compared to the celestial sphere, and we were to draw a horizon line, notice that this would no longer bisect the celestial sphere. You would not have 6 constellations above and 6 below your horizon. You might only have 4 above and 8 below. Since that's not the case, the Earth must be small in size, in fact, very small in size. He says it has the size of a point compared to the celestial sphere. Okay, I'm going to pause there, and next time we'll talk about chapter 7.